Research basically very simple process, unnecessarily complicated by the world, right? You have a research problem, you read literature on the problem, identify a gap, create a hypothesis based on the gap, create a method which answers this hypothesis in the most appropriate manner. In that method, certain elements are important. That is, the sample needs to answer the hypothesis. The design needs to include the sample and answer the hypothesis. The procedure needs to follow the design, use the sample, answer the hypothesis. The analysis needs to use the procedure, use the ethics, use the design, use the right sample to answer the hypothesis. Once you do the data analysis, you have a discussion, right? You have a result and discussion, which either supports the hypothesis or rejects the hypothesis. Either way, it's new knowledge. End of story, right? So it's a very simple linear process. I don't know why people get very irritated by it. It's a logical flow chart, right? So that's the first thing that you need to shove through your head. It's not a complicated thing, right? It's only complicated if you're not able to join the dots, moving backwards and moving forwards and keeping on iterating up and down and up and down and up and down, right? But if you follow, if you read enough, basically in research, if you read enough literature and you can conceptualize that literature in terms of things that are working theoretically, things that are not working theoretically, what is the larger consensus, and not be so forceful about what you think is correct, you'll be fine, right? So it's not so much about the problem that you have found or what you want to find and what you think is the solution. It's about asking the question, seeing whether that question has been answered or not. If it has not been answered, then you find the best way to answer it, irrespective of what you think the answer should be. The time you can block that bit out in your head, you'll be able to do really good research, because then you're plain, you're like a blank slate and you're just trying to find the right answer for the questions you're asking. But that's what I think most people find difficult, because they want a certain kind of answer and they think a certain kind of answer should be correct, which then biases the entire process and you get a research design that may not be very linear or logical, right? So that's the basic mindset, right? So it always starts with a research problem. So the first thing is that the problem needs to have characteristics and meaning, right? So it should be something that makes sense. It must have certain characteristics to it, right? Meaning that it should have certain elements which are important. It's usually in a question form, right? So the problem is, what will happen if this happens, or how do we improve X, or what is the relationship between A and B and C? Does A cause B? Does B cause C? Right? Does B come between A and C's process? Right? What are the other elements that are involved in this? Does this questionnaire answer the item? So it's always a question, right? Saying, is this going to happen, or is this the relationship, or are we going to find this, right? So in that sense, it should be clear. A lot of times I notice is that research problems, people write paragraphs, right? Then that's not a problem. That's a description of a problem. The research question is very simple. This is what I'm trying to find, right? And I don't know the answer to it. That's the basic fundamental of it, right? It needs to be clear cut, saying this is the question. And when you ask the question, it needs to be specific, meaning that it needs to have variables that it's answering, right? It's involved with. It must be answerable. So it can't be a question like, does the unconscious exist or not? Right? How are you going to answer that question? There's no research design you can have. You can maximum have in terms of decision making, how quickly people do it, but you can't ever see whether the unconscious exists or not, right? And we have not developed sophisticated enough tools to actually go into the brain and mind and figure out where what is. We don't even know where the mind is, right? So it needs to be an answerable question. It can't be random, right? It can't be any random variable that you are interested in. It needs to be interconnected, meaning that it can't be away from existing literatures. You can't randomly think, saying that does the change in weather from summer to monsoon cause a change in the cognitive flexibility of human beings, right? That's slightly absurd. It's not connected with reality. There will be no articles you'll find, right? Even in this, at least you might find something, but like sometimes people ask really random questions which don't make any sense, right? You need to have some literature that is based on So a lot of people have this, again, this is a cognitive problem only, where they think that I can find something that nobody has found, right? They want to have this entire thing that I have a new question, I have a very different question, and that sort of thing. But research doesn't require that. We're not trying to like discover laws in physics or anything like that, right? It's important that you find something new, of course, but at the same time, it needs to have some basis, right? All this Einstein and all these people who did quantum and whatever else they did, there was something that was the basis of it, right? They had like time and space and gravity and all of these things. So there needs to be some basis for stuff, right? It needs to be relevant, meaning that you can't do something like in the future 2050 this will happen. Makes no sense. It must have two or more variables. One is also okay sometimes, depending on the research study. Must have some relationship and can be tested by empirical methods. And when we say empirical, both qualitative and quantitative, right? The second thing is hypothesis. Once you have a problem, then you read literature and you develop a hypothesis based on research gaps, right? The important thing about a hypothesis is it needs to be testable, meaning that it must be something that you can assess either qualitatively or quantitatively, but it must be something that you can test, right? Again, you can't have hypothesis being there will be a change in the unconscious desires of the person. You can't test it. How will you ever figure out? There's no measure for it. So it needs to be testable, right? Which means the hypothesis needs to be based on literature, it needs to be conceptually clear, it must be testable, it must be economical and parsimonious, meaning that it should not require so much money that you can't afford to do the research. It should be related to existing theory of fact. Related doesn't mean it has to follow the theory. It can be away from the theory, it can be against the theory, but there needs to be some theory, right? And there must be logical unity. Again, it should be linked. Those variables that you're assessing should be linked, right? The hypothesis that you're creating must be linked. Another thing is the hypothesis should be written in a way where there is a possibility for it to be incorrect. Okay, that's very important. There is falsibility is very important criteria of hypothesis. So there must be the hypothesis must be written in a way where there is a possibility for it to be wrong. So you can't have a hypothesis that says like this relationship exists, right? When you say that, then you're losing out the chance of it being incorrect, because you're already saying it exists. Whereas the way to say it is there will be a relationship, right? And then if it's not, then you say there is no relationship. So it must have that criteria of being incorrect, right? Again, when you discuss the unconscious, for example, you can't be incorrect, you can't be correct either, right? So that's an important criteria for science in general, right? Available scientific tools and techniques must be able to answer the hypothesis, right? So you can't create your own word and then say this word means this, and then if there is no test for it, how are you going to assess, right? Then hypotheses are of different types. So there's causal, which is cause and effect, which the experimental method answers, and there is descriptive hypothesis, which is explaining some characteristics of goal based on an observation or a study, right? So when you try and find a relationship between personality and existential crisis, that's a descriptive hypothesis, right? When you try and find whether your smoking causes cancer, then that's a causal hypothesis, right? A hypothesis can be a simple one with one or two variables. It can be a complicated one, complex one, which has more than two variables. In general, right, hypotheses are two types. There is null hypothesis and an alternate hypothesis, which is also known as the statistical hypothesis. A null hypothesis is represented by H and 0 in bottom and H and 1, right? A null hypothesis is when you say that there is no relationship between X and Y, right? That there is no effect, there is no relationship, there is a negative difference. A null hypothesis is only, I don't know, this is another problem that exists. A null hypothesis can only be used when the theories are not conclusive or previous research is not conclusive about a particular relationship. Okay, you cannot use a null hypothesis just because you feel like it. A null hypothesis can only be used when there is no clarity in the previous literature about what might happen with the two variables that you are discussing. So for instance, if you were studying, say, intrinsic motivation and student engagement, right? Suppose you wanted to see whether student engagement improves with intrinsic motivation or does it decrease with intrinsic motivation, if that's what you want to study, right? And let's take, for example, nobody in the world has studied this, but people have studied intrinsic motivation in its relationship with academic performance, educational qualifications, success, XYZ, right? And these same concepts are linked with student engagement also separately, saying that student engagement is linked with academic performance, it's linked with goals, it's linked with success, and whatever else. But these two variables have not been put together, right? Now, in this sort of a scenario, if you get a situation where intrinsic motivation positively impacts all of these things and student engagement positively impacts all of these things, then you cannot have a null hypothesis, because your literature is telling you that there is a possibility for a positive relationship between these two, because everything else in between that is related is having a positive relationship, right? So in that case, you'll have to have an alternate hypothesis where you make a claim of the existence of a relationship, right? Where there is an operation statement saying that there will be a relationship between these two because the literature is pointing towards that. But sometimes it may be that intrinsic motivation is linked with academic performance, but it's not linked with success, it's not linked with intelligence, it's linked with this. Similarly, for student engagement, something is linked, something is not linked, something is linked, something is not linked. So there's a confusion in the literature, right? In that case, you can use a null hypothesis, saying that I am not sure, I've read this literature for 50-60 pages and each of them are telling me inconsistent things. So it is not possible for me as a scientist to say that there will be a relationship. So what I am saying is there will be no relationship. I'll test it, and once I find the finding, then I'll say whether null hypothesis is supported or rejected, right? So in that case, you are allowed to use the null hypothesis. That's basically the only criteria.